Okay, so welcome back. Hope you had a wonderful holiday. Hope you're feeling well rested. So, if you recall, right at the end of last term, we sort of finished the unit and we're looking to have the test Thursday next week. Okay, so today my plan is to do a pretty comprehensive recap. Alright, like we did with the first test, I've got a list of skills that you're going to need, and then I've got some examples. Now with the examples, this time rather than opting for sort of really challenging questions, I've opted for more skills based. I'm more targeting the skills as opposed to them being sort of challenging. We'll come across that in the formative tests that we do. So today we'll have a bit of a recap. Tomorrow we'll do a formative test under those sort of, individually, sort of open book, have a go at it yourself. We'll give it a mark here, see how you go, see what it is you need to practice. Got lots of extra resources. Gives us, sort of that weekend to revise, Tuesday to revise, coming up to the test on Thursday. So that's our plan at this stage. Now, I did send home some holiday homework. So hopefully you had a look at it. My assumption is that you've done it, okay? And if you have questions about it, please do let me know. But my assumption is going to be that you've done it, and I'll come around and see how you're going with it all. So to begin with then, let's have a read through of the skills checklist. Let's read through the skills checklist. And I think it's going to be helpful if you either flick through your textbook or if you flick through your notes book. Pull out either of those and we'll accompany that and we'll see how we're going to go with this skills checklist. And it might be helpful for you to jot down what exercise each particular skill corresponds with. So you can do that as we're going through it. So we started with chapter 2A. So that's at the front of your notes book for polynomials, or chapter 2A in your textbook. So I've written down there, we're going to be solving quadratic equations using factorization, completing the square, quadratic formula, and technology. So factorization is 2A.1, completing the square is 2A.2, and quadratic formula is 2A.3. Using your calculators, that's something that sort of we've tapped on throughout the whole throughout the course of the whole unit. So that in a moment we're going to go over all four of those skills again. Okay. So that's the first checkpoint. All right, so we'll move on to the second one, which says solve the discriminant of a quadratic and identify what the value of the discriminant means for the graph of the quadratic. So this is exercise 2B and 2D.4. Okay, so the discriminant is touched on in 2B. They introduce you to the calculation of it. And then in 2D.4 we look at things like positive definite and negative definite and so forth. Alright, so that's the second dot point. Alright, we'll move on to the third. We've got graph quadratic equations from linear factor form, completed square form, and general form. So we've brushed over 2C. Alright, if you remember, we spent maybe 15 minutes going through 2C, and I said it's something that's in the Year 11 curriculum, but it's not something that's sort of assessed at a Year 12 level or something that's really necessary. Although I encourage you to do some of the later ones if you like the problem solving aspect of it. So 2C we've brushed over. The third dot point then is about exercises 2D, 1, 2, and 3. And when we did it rather than doing it based on the exercises, we did it based on the skills. So we did the first skill was graphing from linear factor form. All right, and so we did a couple of questions from 2D1 and a couple from 2D2. Then we did graphing from completed square form. So we had a couple of questions from 2D2, and then we did graphing from general form, which was in 2D3. Okay, finding the equation of a quadratic from its graph. So we're given a graph, and then we're doing the opposite. We're determining the equation of it. That's exercise 2E. Now, turning points for a quadratic, so that's where the local max or the local minimum occurs. So we touch on that in 2D.3, but we also touch on it when we're doing optimization, when we're finding the optimal solution, which is 2H, optimization. So I've got the three methods that we need for finding the optimal solution. Then we had determining when a quadratic meets or is tangent to a line. Okay, so using both algebraic methods and technology. So that one is in 2F. There will be some problem solving. That's exercise 2G. So that's where we're confronted with some problem. We need to develop the equation. That'll be the first part, a couple of marks for developing the equation. And then the second part, a couple of marks for solving the equation. All right. So that's 2G, and then 2H, finding optimal solutions to problems involving quadratic equations. That's the optimization, right? Okay, so then we moved from chapter 2. Most of the test is chapter 2, right? Remember, we spent sort of 4 or 5 weeks going over chapter 2, and then we spent a single week going over chapter 4. So let's fast forward to chapter 4, where we start to talk about polynomials. We didn't do all the exercises in polynomials, we just picked out the essential ones. So firstly, we talked about the degree of a polynomial. All right, so we talked about all that language around it. That means what's the highest power of the polynomial. So that's in exercise 4A.1. We had a class discussion about that, right? We just talked about it, and then we moved on and did the exercise for 4A.2. So when we're equating polynomials to solve unknown coefficients of quadratic and linear factors, that's in 4A.2. Factorizing cubics is in 4C. And then graphing cubics and quartics from linear factor form and using technology is both 4D and 4E, as is the last one, finding cubic and quartic functions in general form, 4D and 4E. Okay, so at the bottom there, I've gone through the chapter review sets, and these are the questions that I recommend doing. The ones that I've left out are sort of beyond the scope of what we need to assess or aren't really necessary for what we're targeting. So they're the questions that you should have a look at. Okay, so let's turn the page then, and we're going to go over these 6 questions together. So you might remember last time we did our comprehensive review, it was very thorough, it was very in-depth. This one I've said I want it to be more about skills, so it won't take us as long, and it's going to be more directed towards the skills we need rather than the complexity we need. Okay, so these are easy questions is what I'm saying, and the reason I've selected easy ones is because, while I'm hopeful that people have done their holiday homework, I also recognise, enjoying your holidays, having a good time, maybe it slipped your mind. Okay, let's get straight into it. Consider the quadratic equation. We've got x squared plus 3x equals 0. Now firstly, can everyone see that ink? I can't really do any better than that at the moment. My black ones are sort of running out. Everyone can see it okay? Harry? Yep. So if you can't, maybe move a bit closer. Charles, sliding one of those. So we've just read through the skills checklist, and now we're about to start these questions. So we're going to solve this using all of these different techniques. Okay, so this is question 1, and first we're going to solve it via factorization. So if we're solving via factorization, we have to either use the cross method or pull a common factor out the front. So if I'm looking here, I'm not going to use the cross method because we don't have that constant number here, do we? Instead, we've only got 2 terms, and x is common to both of them. So I'm going to factorize x out the front. Okay. Then we're going to apply the null factor law. X is 0, or x plus 3 is 0. And then solve through for x here. We've got our 2 solutions. So that's the first way of doing it. That's factorization. All right, now remember, factorization does increase in complexity. We have the monic quadratic trinomials, we have the non-monic quadratic trinomials, but again, I'm just talking about this as a skill that we need, isn't Okay, let's do it by completing the square. So if we have x squared plus 3x is equal to 0. Alright, now we did completing the square in two ways. We did it when we had y equals, so we did it when we have the graph of a quadratic, and we do it when we're solving a quadratic equation. What we have to do is add half of b squared to both sides. Alright, so b is 3 on 2. So I'm going to add half of b, so 3 divided by 2, half of it, squared to both sides. Okay? Now, because we've added 3 on 2 squared to both sides, the square completes. Pass through, mate. Alright, and so remember, I'm going to write this step here. Although this isn't necessary for our for solving it. Okay, so we've got a squared plus 2ab plus b squared. And so because we've written it like that, it collects to x plus 3 on 2 squared equals 3 on 2 squared. Okay, we're moving from here to here. That's a completed square. Let me write that rule up. A squared plus 2ab plus b squared is equal to a plus b squared. If we expand that, this is what we get. If we have this, we can factorize it to that. This is what we've got here, okay? A squared plus 2ab plus b squared, and so this is what it collects to. Okay, then what we're doing, if we're trying to solve for x, we're going to square root both sides, right? So I'll go through, I'll square root both sides. We're going to have x plus 3 on 2 equals plus or minus 3 on 2. Plus or minus 3 on 2. Alright, because when we perform the square root of something, we get the plus or minus. Now the square root is getting rid of the squared on both sides, isn't it? So I've got x equals 3 on 2 plus 3 on 2, or 3 on 2 take 3 on 2. Alright, here, 3 on 2 plus 3 on 2, that becomes 6 on 2, and 6 divided by 2 is 3. And here, 3 on 2 take 3 on 2, 0. Alright, and so notice how we have the same solutions. We've used a different process, but we've arrived at the same solutions. What have we got wrong there? Why have we got minus 3 and positive 3? So here, when I move it across, okay, yeah, so what I'm doing is when I'm subtracting minus 3 on 2 to both sides, isn't it? So this here should be minus 3 on 2. Alright, so we have minus 3 on 2 plus 3 on 2, so that one becomes 0. Or here, minus 3 on 2 take 3 on 2, that's minus 6 on 2, which is minus 3. Alright, and so again, that's what's helpful about solving in multiple ways, is it allows you to check your solutions. I'm going, where have I made an error? I know I've made an error here somewhere. Here's where it occurred. I just assumed when I move that over it stays positive. No, what I'm doing to isolate x, subtract 3 on 2 from both sides. So I move it over, minus 3 on 2 plus that part, and minus 3 on 2 take that part. Okay, so that's factorising by solving by completing the square. Let's use quadratic formula next. Alright, so the quadratic formula is minus b plus or minus square root b squared take 4ac. And if we're looking at this quadratic here, we have x squared plus 3x. Okay, we've got a is 1, the coefficient of the x squared term is 1. We've got b is 3, and c is 0. There is no c, so we can have c is 0. So let's put that in. So we've got minus 3, the square root of 3 squared, 2a. All right, so quadratic formula is nice, right? You just put the numbers in, process it, crunch it, answer. All right, we'll keep going here. Now here I've got 4 times 1 times 0. That's going to be 0. And so in the square root, we're just left with 9. All right, we'll keep evaluating this. Minus 3 plus 3 on 2, or minus 3 take 3 on 2. All right, minus 3 plus 3 is 0 on 2, which is 0. Minus 3 take 3. Okay, so just processing the numbers. The square root of 9 is plus or minus 3. So we've got the positive 3 in that circumstance, the negative 3 in that circumstance, and then just following it through. Okay, any questions at this stage? Everyone feeling okay about it? Yep. Kevin, all good? Yep, Austin? Excellent. Okay, so last one then, using technology. So pull your calculators out. I'm going to rewrite the instructions up here again. So in menu, we're going to do it in 2 ways. We're going to use 2 procedures to solve the quadratic equations. Okay? The first one is to go equation, polynomial, and the degree of this polynomial is 2 because it's a quadratic. So do this in your calculator now, make sure you can do it. And then you just have to input the values of A, B, and C. So we have A is 1, B is 3, C is 0. All right, make sure you can do it when you press solve. What'd you get, Charlie?
0 and minus.
0 and minus 3. What are the chances? Okay, very good. So again, we can use our calculator to confirm our answers, right? This is a way of checking during the test to see if you've got it right. You can go through and check it all out. So that's the first one, right? We're saying what values of x make this quadratic equal to 0. Solve that equation for me. Must be equal to 0, right? Very powerful tool, this technology. You've got your calculator in this test. Make sure you use it to support you, yeah? Okay, the other way, and here's the significance of what this graph means for us. You guys got your IMS or something? All right, here we go. Yeah, go. The other way is to graph it. So from menu, if we go to the graph mode and we type in y1 equals x squared plus 3x, all right? And if you graph it, this is what it's going to look like. All right, so we don't have to do this one, but I'll just explain this one. You're very welcome to do it, okay? Again, use your calculator to support you. We're graphing it. This is what it's going to look like. And if we're saying, remember, we've got y equals x squared plus 3x, all right? Y equals, and we're asked, when does this equal 0? We're saying, when does y equal 0? Well, y equals 0 here and here. That's the roots of the quadratic. They're the x-intercepts. So you just go bang, g solve root. G solve the roots, and use your cross arrows. You'll have 0 and minus 3. So look at all of these ways we can arrive at the same answer. Okay? So we've got factorization, we've got completing the square, we've got quadratic formula, and using technology. Now you need to be competent at all of them because in the test, the way it's written, it often, not all the time, but often wants you to use a particular process. It'll say, solve the following quadratics via factorization. Solve this quadratic using the quadratic formula. So we need to know how to do all of them. All right, so that's question 1. Let's move on to question 2. So here we have one about the discriminant. Okay, so in our first circumstance here, when we're solving for the discriminant, or like when we're using quadratic formula, we need to know what's the value of A, what's the value of B, and what's the value of C. Alright, then we go delta equals B squared, take 4AC. Alright, and then it's just numbers, just evaluating the numbers. Okay, again, you've got your calculator here, so just use it. Alright, use it to help you. So we've got 9 take 16, I've got -7. Okay, -7. What does this tell me about the quadratic? The discriminant is negative, which means it has no roots. There are no values that make it equal to 0. It doesn't cross the x-axis. All right. Now, let's also reflect on my A, my value of A, my coefficient of x squared is positive. So this is a good opportunity to bring this in. Remember, if A is positive, we're going to be happy, smiley face. All right, if you're positive, you're happy. And if you're negative, then you have a sad face. Okay, we've got A is positive, and it has no roots. So this is a special type of quadratic that we call positive definite because it is completely positive. It's completely above the x-axis. Every value of y on this function has a positive value. So we've found the discriminant, no roots, all right, is the shorthand, and then for the extra bit, we'll just say positive definite. Definite. All right. On to B. X squared plus 6x plus 9. So we'll identify A, B, C. Discriminant is 0. Yeah, go for it. Discriminant is 0, therefore 1 root. If there's 1 root, that means the function touches the x-axis, right? If you think about the graphs, let's think about graphs of quadratics. You could have it completely above, you could have it touching, or you could have 2 roots, right? So no roots, not crossing the x-axis. 1 root, touching the x-axis, 2 roots, cutting the x-axis twice. All right, so that's part B. Let's move on to C. We've got A is 1, B is -3, C is 2. Now, whenever we're doing B squared, it's always that number in brackets squared. So it becomes positive 9. Take 8, it's 1. So the discriminant is 1. It's a positive number, which means it has real roots, but it's also a square number. All right, what are the square numbers? 1, 4, 9, 16, 25, all right? Square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. If this is a square number, all right, which means we have that extra caveat, the roots can be found by factorization. So 2 real roots, all right, that's because the discriminant is positive. It's a positive number, 2 roots. 2 real roots. The second part can be found via factorization because this is a square number. Very good. All right, that's question 2. Okay, any questions about 2, about the discriminant? So that's 2b and 2d.4. All right, on to question 3. Now this is an important question. This is a real consolidating question. We've got y equals x squared, take plus 2x, take 3. Okay, y equals, we've got a quadratic. Now firstly, everything it's going to ask here, you can get, Mason, come grab yourself a sheet here. Just had some immunisations. Yeah. So we're just going over this skills checklist. So we've talked about that already. And we're up to question 3 now. Just doing a recap. Yeah. All of the information that you need to solve this question, you can get from your calculator. Alright, so be aware of that. Alright, so firstly it says state the y-intercept. So I think what we'll do, we're going to do this manually first, then we will graph it and I'll go through how you can get all of these from your calculator. So firstly, the y-intercept. Well, the y-intercept always occurs for any quadratic when x is 0. When x is 0, that's when it's going to cross the y-axis. So if you put x is 0 into this equation, that's the y-intercept. Okay, the y-intercept is -3. Now, we have that written down at the back. At the back of your notes book, you've got sort of a list of all of the formulas and information you're going to need around quadratics, or formulas, techniques, and so forth. And one of them says the y-intercept for a quadratic in general form is, all right, if we have y equals ax squared plus bx plus c, the y-intercept is always c. Okay? So here, the y-intercept is -3. All right, we're spending too long on that. State the quadratic in linear factor form. Okay? So linear factor form is like this, where p and q are the roots. All right? So if we want to, that means we need to factorize it. We need to use the cross method to factorize this. So we're looking for 2 numbers that multiply together to be -3. And when you add them together, you get +2. All right, 2 numbers, they multiply together to get -3.
1 minus 3.
1 and -3, other way around?
Minus 1
-1
and 3.
and 3. So if we have -1 and 3, right? -1 times 3 gives me -3. -1 plus 3 gives me +2. Okay, so here's the product, here's the sum. So this factorizes then. This is in exercise 2.8.1, so factorizing monic quadratic trinomials. It's a skill you need to practice, that's where we'll look. Y is equal to x plus 1, x take 3. Maybe other way around, sorry. The roots are 1 and -3. Okay. So this, we've expressed it as linear factors. Okay? Expressed as linear factors and hence state the roots. Well, the roots occur when it's equal to 0. Apply the null factor law. So we'll have x take 1 is 0, or x plus 3 is 0. So we've got roots minus 3 and positive 1. Okay, so two parts to that. We start from something in general form, factorize it into those linear factors, and then solve that equation. Right? Solve the roots means make it equal to 0, solve through for x. Alright. State the quadratic in completed square form, and hence state the vertex. So we're going to take this quadratic and we're going to complete the square. So that's for part C. Now, when we did solving via completing the square, we added b on 2 squared to both sides. Now, while you can do that here, my preferred method is we're going to first add b divided by 2 squared. But because we've added it, in order to maintain equality, we need to subtract it. All right? This expression and this expression are the same. 2 on 2 squared, take 2 on 2 squared, they just cancel. All right? It's the exact same expression, but we're manipulating it, aren't we? We're sort of rearranging, we're adjusting it because we want to complete the square. Alright, so this becomes x squared plus 2x plus 1 squared. Take 3, take 1 squared. Here, the square completes. We've got a squared plus 2ab plus b squared. Alright, remember, it goes to x plus 1 squared. And then over here, we have take 3, take 1. That's going to be minus 4. So, it's in completed square form, and completed square form is like this, right? X take h squared plus k, where h and k are the coordinates of the vertex. H and k are the coordinates of the vertex. So what's our vertex here? Minus 1 and minus 4. Minus 1 and minus 4. Okay, hence graph the quadratic. Alright, so we've got a Cartesian plane. We have a y-intercept of minus 3. We have a vertex of x is minus 1 and minus 4. So that's the local minimum, alright? I have a positive a value, which means I know it's opening upwards, and it has roots. X is 1 here, and x is minus 3 here. So we've got 1, that's minus 3, minus 4, minus 2, minus 1, minus 1, minus 2, minus 3, minus 4, okay? And then it's going through those points, right? Label your axes, provide a scale. So we did all of that manually. Okay, we did all of that manually using the different forms of the quadratic. We have the general form, okay? We have linear factor form and the completed square form. They all tell us something different. I'll just grab this, Jolie. On the back of your book, that's expressed very clearly forms of quadratics. Okay, they all tell you something different, and this question's a great one because it's getting you to employ all of those relationships. Okay. So what I do want to do, I want us to talk about how can we use technology to garner all of that, or to support it. So let's go, again, with our calculators, menu to the graph mode. We're going to delete whatever you had in terms of y1, and we're going to put in this new function that we've got here. X squared plus 2x take 3. If you're struggling, like if you're finding this hard, use your calculator. Really, if you're finding the algebra really hard, you've got to sort of work out how can I use my calculator to help me answer all these things. So let's go through that right now. We're going to graph this function. Remember about the V window? Okay, the V window is the window over which you're viewing the graph. That's the restrictions of your Cartesian plane. And I always just set it to standard, right? Minus 10 to 10 and minus 10 to 10. So set your V window to standard and we'll get a nice looking graph there. Okay, so the first thing is in GSolve. Alright, if you're pressing GSolve, you'll notice all of the options that pop up for you. There's y-intercept, there's root, there's max, min, intersection, that's if you've got multiple functions and you want to GSolve the point of intersection to it. Oh, minus 3, not minus 4, sorry. Yeah, thank you. Yeah, I wrote it right. Yeah, I didn't draw it right here. Okay, so we've graphed it. So let's go through. What parts do we need? Okay, to get the y-intercept, GSolve, y-intercept. Okay, that's worth 1 mark. I don't care if you use your calculator to get it. You get 1 mark for stating the y-intercept. Done. Okay, roots. All right. It does say factorize it and state the roots. If you can't factorize it, doesn't matter, you can state the roots. You get a mark for that. Okay? So there's still ways of, like most of this, the marks in this question you can just get from your calculator. And even then, once you've got the roots, perhaps you can see, you can reverse engineer this. You can go from there to here. You can pretend that you factorized them. All right? Use the calculator to support you, yeah? So GSolve the roots and you can navigate across using your calculator. And then the other one is the vertex, okay? Here you need to know, is it a maximum or a minimum? Well, this is a minimum, it's the lowest point. GSolve that min, and it's going to list both coordinates for you. Again, you can reverse engineer that. You can go from the vertex to this statement. All right? And then lastly, like if the last part is to graph it, that's worth 3 marks. It doesn't matter if you've done any of this stuff before because you can copy it from the graph that you've got there. You can trace along it, get all of the information you need, plot it on the Cartesian plane. Okay, so make sure you do use your calculator to help you out with those. Any questions about that one? Very good. All right, let's move on to question 4. We've got, find the equation of the following polynomials. So we've got a quadratic has a vertex of -1, 2 and a root at 2. So this is going to be good. A vertex of 1 and -2. X is 1, y is -2, and a root of 2. Alright, so that's what we know so far. Okay? Now, there's 2 ways we can go about solving this problem. The first is to use the vertex form, right? Remember we have y equals a times x take h squared plus k. We've got the vertex, so we can put that in. We would have x take 1 squared, take 2. Alright, h is 1, k is -2. We put the 1 there, we put the -2 there. And then, okay, so we've used that first piece of information. We need to use another piece of information to solve for a. We go when x is 2, y is 0. When x is 2, what's the y value here? Because it's a root, y is 0. So we put 0 where the y is. We put 2 where the x is. and solve through for A. Okay, so that's one way. The other way, the other way to solve this is to go, this is the vertex, but it's also the axis of symmetry. Okay, so I'm making a connection here. Now the axis of symmetry, the x value, you might remember, is at minus b on 2a, but the x value is also exactly halfway between the roots. Alright, so if this root is 2 and the vertex is at 1, that distance is 1. Alright, so the distance from the axis of symmetry to here is 1. That means the distance to the next root is also 1. So the other root is this point here, right? And so that's our quadratic. And so the root is 0 and 2. And so you could go through with this quadratic and solve it in linear factor form. Alright, x take 0, I'll write it like this for now. X take 2. Alright, x take 0, x take 2. Here's what it will simplify to. X times x take 2. And then, so you've used both of those pieces of information, then you'd need to use this one. When x is 1, y is minus 2, and solve through for A. Okay, so that's question A. Let's move on to B, unless there's any questions about that. So if you remember, when we're doing these reviews, if it's a skill you need to practice, make a particular mark of it, and I can provide plenty of revision around particular skills that you might need to focus on.
Does it matter what we use?
No, it doesn't. Doesn't matter at all. No. Yeah.
And when it says find the equation, does it mean you have to leave it in a certain form?
Yeah, that's non-specific, isn't it? So here, you found A is 2, so you just restate 2 times x, take 1 squared, take 2. You get full marks there, unless it specifically specifies a form. Sometimes it'll say find the equation in general form, and so that means you can do either of these, but you just have to expand it at the end. So yeah, good clarifying questions. Yep, really good. Okay, so we've got a cubic, touches at x is 1, cuts at x is minus 1, and has a y-intercept of 4. So, if it helps, sketch it. So we've got touches at 1. So it's touching there, and it's cuts at minus 1, and it has a y-intercept of 4. Alright, so it's cutting here, passing through there, and then touching here. Alright, they're the only locations it gets anywhere near the x-axis. So here's positive 1, here's minus 1. Now, what we should remember, if we have it touching, it's a squared factor. And if we have it cutting, it's a linear factor. Alright? And maybe I've skipped a little bit there. So remember what we're doing is we're always subtracting the roots. We have x take that root squared. Here we're going to have x take minus 1. Okay? Now this one is not squared because it's just a cut. This one is squared because it touches at that point. So keep processing here. Okay, so we've got that, and in order to determine the value of A, we need to use another piece of information where we've got the y-intercept is 4. So our y-intercept up here is 4. So we've got when x is 0, y is 4. Alright, so once you put the information in, it's just a matter of processing it and restating the equation, right? Okay, question 5, we're getting there. Determine the value of c for which the line 2x plus c is tangent to the quadratic. 2x squared take 3x plus 4. So we have 2x squared take 3x plus 4, and we have 2x plus c. Determine the value of c to which they're tangent. Okay, so when they're tangent, what that means is they touch, there is one solution. So remember, these lines, this quadratic and this line, they're going to meet when they're equal to one another. And we're saying, what are the values of c for which they meet? And there is only one solution. So that means we're going to move all this across, right? We're going to have 2x squared take 3x plus 4. And then we're going to have take away 2x, take away c. All right, and then we're going to collect what we can along there together. So I've got 2x squared take minus 3x, take 2x, that's minus 5x. I'm at minus 3 and I take away 2, minus 5. And then here plus 4 take c. That's our constant term. And so this is what it collects to. And so this equation here has the same solutions as this equation here. All right, this equation has the same solution. Now we're saying what values of c does this quadratic have? One solution. One solution occurs tangent when discriminant is 0. So we're taking this quadratic equation and we're going to find what is the value of c when the discriminant is 0. So if we're going to solve the discriminant of it, we've got a is positive 2, we've got b is minus 5, and the c is this collection here, isn't it? 4 take c. Sorry, that's not very good. Minus 5. So let's calculate it. B squared, take 4ac. That's the discriminant. When z equals 0. Got your names, guys?
Still thinking about inoculations.
Yeah, no worries.
I know it's a messy day. but-
Yeah, it is. It certainly is, isn't it? Yeah. All right. So let's just quickly chat about that one. Okay. Whenever we have these questions, there'll be one pretty similar to this. Okay. We've got when does a quadratic tangent to a line? When's the line tangent to the quadratic? Well, we find when they meet, and it's when they meet has one solution. So you make them equal, shove it over, collect like terms, make the discriminant equal to 0, solve the discriminant. Okay, that's it. That's 4 or 5 marks there. All right. So always the same process. Again, if that's a skill you need to practice, let me know. That's in exercise 4F. Okay, question 6, last one. All right, so this is from polynomials. We have x take 1 is a factor. So just to reiterate, those words are factors, roots, zeros, solutions, essentially mean the same thing. Okay, so if we've got x take 1 is a factor, okay, if x take 1 is a factor, that's what we're told for this one, then what it means is 1 is a root, or 1 is a 0, or 1 is what we call a solution. That it makes the equation equal to 0. So we sort of use these words interchangeably, right? Another one, x-intercept. Alright, if the x-intercept is 1, then the factor is x take 1. Okay? So if you can be given it like that, we can go from roots, zeros, solutions, or x-intercepts to there, or if we're given factors, we can go from the factor to here. Alright? So, we're told this is a factor. And so what this means is we have this linear term, multiplied by something here is going to equal this cubic. So then we're going, well, what kind of polynomial has to go here such that when we expand this left-hand side, we get a cubic? All right? Has to be a quadratic, very good. Ax squared plus bx plus c. Has to be some quadratic. All right, because now when you expand it, x times ax squared, you get x to the power of 3. The highest power is a cubic. Okay, so there's a question like this, and it's fairly scaffolded, like it'll get you to fully factorise it first, and then find the y-intercept and so forth, find the roots and graph it. So, let's perform this expansion. Okay, let's perform this expansion here. So remember the staggering method, so we're going to go x, firstly we're going to take the x and multiply it by every term in here. We'll have ax to the 3 plus bx squared plus cx. Alright, so we've multiplied the x through, and then we're going to take the minus 1 and multiply that through. Alright, minus 1 times ax squared is minus ax squared, and I'm going to write it beneath here because they're both x squared terms. Minus 1 times bx is minus bx, and I'm writing it beneath here because they're both x terms. And then minus 1 times c is just minus c. Alright, we'll collect it. So in brackets then, I'm just going, oh yeah, positive b take a. And then in brackets here, positive c take away b. Alright. Now, this cubic is equal to this cubic, which means the coefficients of each respective term are equal, right? Ax to the power of 3 equals x to the power of 3. So a has to be 1. Alright? And then you've got b take a, the x squared term, b take a is equal to 4. We know a is 1. So we've got b is 5. And then for the c term, okay, yep, you can use this one if you want, or you can just look at the end. Here I've got minus c and minus 6. Minus c equals minus 6, therefore c is positive 6. Okay, so what have we done? Like, let's rewrite x squared plus okay, so here the cubic is expressed in what we call general form. It's fully expanded. General form tells you the y-intercept. The y-intercept occurs when x is 0, right? Here we've got expressed as a linear factor and a quadratic factor. So we've found the quadratic factor. Alright, so that's worth maybe 3-4 marks there. The next part says fully factorize the cubic. Okay, fully factorize it. Well, that means we need to factorize this quadratic part. We can factorize that using the cross method. We've got x squared plus 5x plus 6. I'm looking for two numbers that multiply together to give me positive 6. And when I add them together, I get positive 5. 2 and 3. 3 times 2 is 6. 3 plus 2 is 5. Alright? So look at all these different ways of expressing this cubic. We've got the general form. We could express it as a linear factor and a quadratic. We could express it as the 3 linear factors. Okay. So then from here, when it's expressed like this, you can see the roots. You can see the roots because you know what would make this cubic equal to 0. Well, if I put 1 in there, the whole thing is 0. If I put minus 2 in there, the whole thing is 0. And if I put minus 3 in there, the whole thing 0. We're applying the null factor law, right, like we do with quadratic. We're going like this. X take 1 is 0, or x plus 2 is 0, or x plus 3 is 0. You've got minus 3, you put minus 3 in, the whole thing is 0. You put minus 2 in, the whole thing is 0. These are the x-intercepts. These are the x-intercepts, okay? What's the y-intercept? The y-intercept is minus 6. Y-intercept when x is 0, so we can cover up all of those. The y-intercept is minus 6, okay? And again, all of that information we can get from the graph. Even if you can't get these first 5 marks, okay, sort of 4 here, 2 here, you can just go to your calculator and graph the equation that it gives you. You can graph it and you can g-solve all of the x-intercepts and all of the y-intercept. Okay? So if we're going to graph it, alright, I've got a y-intercept of minus 6. Okay, so I've got y-intercept there, and I've got roots at x is 1, x is minus 2, and minus 3. Alright, so it's going something like this, right? 1, 6, minus 2, minus 3. Draw your scale, label it, use your graph. Okay, you plot that in your graph, it's going to show you where it's reaching its max and min and so forth. We have got the dilation correct as such, but we've got all of the important pieces of information that we've generated from this algebraic process. So there will be a question like that as well, and it will be staggered over parts. It'll be like, find the quadratic factor, now factorize the quadratic factor, now tell me all of the roots and the y-intercept. And now that you've garnered all that information, from what were we told? You're told this is a factor of this. And so you perform all that algebra, and then you go, yep, let's sketch it. Alright, but so it's about, you know, yes, we're doing the algebra, but using your calculator to support you. Because you can go back, you can get, again, you can g-solve those roots, and if you can g-solve those roots, you can go to here, and then you can reverse engineer it and move backwards if you really need to. Alright, really good. So that went way longer than I thought it would. So